There's a very important problem type in functions, which is finding the analytical expression of a function using the coefficient substitution method. Although it's relatively simple, no one scored points on this question. Let's see why there must be a trick to it. If function y equals kx plus b, where k is not equal to 0 when x is greater than or equal to 0 and less than or equal to 2, then y is greater than or equal to 0 and less than or equal to 6. What is the analytical expression of this function? So many students analyzed it. The teacher said it's simple, right? I'll just draw a straight line where y equals kx plus b. You said x is greater than or equal to 0 and less than or equal to 2, right? And y is greater than or equal to 0 and less than or equal to 6. So this line must pass through the origin, right? It says y equals kx plus b because when x equals 0, y also equals 0. And when x equals 2, this is x equals 2. It corresponds to y equals 6, right? So y equals 6. This means the point is 2, 6. One point is 0, 0. The other is 2, 6. 2 corresponds to 6. So we know this line passes through which 2 points, 0, 0, and 2, 6. So according to our coefficient substitution method, we substitute these 2 points into the original equation to solve for k and b and get the analytical expression of this linear function. So let's substitute 0 equals 0 plus b, right? Then 6 equals 2k plus b. So we get b equals 0 and k equals 3. So our linear function is y equals 3x. Thus, its analytical expression is y equals 3x, right? But if you calculate it this way, for this fill-in-the-blank question, you'll get 0 points. Absolutely 0. Think about it. This is just one possibility. This is just one scenario. Think about it. Here, x has an upward trend, but could there be another case? When x equals 0, y equals 6. When x equals 2, y equals 0. When x equals 0, y equals 6. It passes through point 0, 6, right? And when x equals 2, y equals 0, x equals 2, y equals 0. So it's on the x-axis. Could it possibly look like this? It's a downward trend. Don't just assume one solution. It is an upward trend. It could also be a downward trend, right? So that means this 0 and 6 correspond, and this 2 and 0 correspond. Of course, x could equal 0, y equals 6. At this point, x equals 2. What does y equal? Y equals 0 at this point. Isn't x greater than or equal to 0 and less than or equal to 2? The function value y is also greater than or equal to 0, less than or equal to 6. So which 2 points does it pass through? The points 0, 6, and 2, 0. So if you take these 2 points and put them into the function formula, let's look at the first one, 0, 6. So 6 equals b, the second one, 2, 0, right. So the function value 0 equals 2k plus b, we solve that. B equals 6, then k equals minus 3. So it's possible that y equals 3x plus 6, right? These two situations are both possible. Both are possible. So when considering the problem, you must be comprehensive. That's why we recommend thinking divergently many times. If you don't consider these situations, you'll get no credit, right? So our answer to this question should be what? Y equals 3x, or y equals how much? X plus 6. Write it like that. Write it on this line.